All right, deductive reasoning. Two CLTs. I can use the law of detachment. I can use the law of syllogism. You are going to get those definitions right now. So the law of detachment. All right. Once again, today we're going to deal with a lot of sentences. You're going to be telling me if things are valid or not. If they are, you just write it. If they're not, then you don't. But what the law of detachment says, we're going to use P and Q again. So if P, then Q. If this statement is true, so we're assuming that if P, then Q is true, so if this statement is true and P is true, then Q is true. So if P then Q, if that statement's true and P is true, that means that Q has to be true. And you'll see what I mean here in a second. Once again, remember these notes will all go to you, so if you miss something, you'll have it right after class. All right, so we're given that BD bisects angle ABC. All right, that's the given. The conclusion is angle ABD and angle CBD are congruent. So if we were to draw this, we're given, we have ABC. And we know that BD is a bisector. What's a bisector? What's a bisector do to an angle? Divides it, cuts it in half, whatever. So if we know that this is an angle, and we know that DB is a bisector, do we know that ABD, this angle right here, is congruent to CBD? Is that a true statement? Is it valid? Yes, it is. If BD is a bisector and it bisects this angle, then this has to be true. So it is valid. All right, let's take a look at this one. We're given that PQT and angle RQS are congruent. So we know that this one is congruent to this one. Because those two are congruent, do we know that QT is a bisector? We're given that those two angles are congruent. Is QT a bisector of the whole thing? What if I drew it this way? So I had P, Q, T, and then I had R, Q, S. So I know that this is congruent to this. Is QT a bisector of these angles? No. No. I mean, isn't that the same thing? They told us that these two angles are congruent. Okay. But that doesn't mean anything. It just means they're congruent. We can't deduce that QS and QT are angle bisectors. First of all, there's two lines. If I have an angle bisector, how many lines do I have? One. Or three if you use the two sides, yeah. Not four. So this is not valid. All right, now we have the law of syllogism. This says, if P then Q. If that is true, and if Q, then R. If that is true, then we can say that if P, then R. Okay, if I break it up into numbers for you, if I do 5 times 2 equals 10, and 10 equals 5 plus 5, then 5 times 2 has to equal 5 plus 5. That's what it's saying. Make more sense that way? So if two things, if P then Q, and if Q then R, then you can say that P then R. So let's look. This is LE, AE. So if the symbol of a substance is Pb, then it's lead. The atomic number of lead is 82. Can we say that? So can we say that Pb is 82? Yeah, it's just like this one up here. Because the lead is the same, then we can say that Pb is 82. How about the next one? Water can be represented by H2O. You all know that. I know the 2's big, but that's all I can do. Hydrogen and oxygen are in the atmosphere. Is there a conclusion to be made here? So here we made the conclusion, because of this first one and this second one, we could conclude that lead, or Pb, this one right here, is 82. Water can be represented by H2O. Hydrogen, H, and oxygen, O, are in the atmosphere. Does that tell us anything about water? But do you know that from this statement? No. We cannot conclude anything from this. We know two things. We know that water is H2O, and we know that hydrogen and oxygen are in the atmosphere. But we can't conclude that they're going to bond up in the atmosphere. So there's no conclusion here. So let's take a look at this one. We have vertical angles are congruent. If two angles are congruent, then their measures are equal. And if two angles are vertical, then their measure is equal. So they want us to state which law we're using and if it's valid or invalid. So if we know that two angles, vertical angles are congruent. We also know two angles are congruent, then their measures are equal. If two angles are vertical, then their measures are equal. Can we say that? Okay, if we have P, Q and R. All right, we say that P, two angles are vertical. And then Q says that they're congruent. And then R says the measures are equal. So is this valid? Yes. Because if two angles are vertical, then their measures are equal. Because we know that two angles are congruent. Two angles are vertical, they're congruent. Congruent angles have the same measure. So we're just skipping the Q and we're saying P then R. So two angles are vertical, their measurements are equal. So yes, by the law of syllogism. Okay, let's try one more. A figure is a square, if a figure is a square, then it's a polygon. Okay. Figure A is a polygon. So if it's a square, then it's a polygon. Figure A is a square. Figure A is a polygon. Can we say that it's a square? Do any of our laws say that we can just turn P and Q around? What's that called? This is if P, then Q. Yeah, if we say if Q, then P, does that always have to be true? No, it's a converse, right? So, is every polygon a square? No. What else could it be? Okay. Anything, right? All right, let's go to page 84.